Today we're going to be doing 2.4, the graph of y equals kx. So we're going to be skipping a couple sections because I feel like it kind of hops to different types of topics. The first one was 2.1, direct variation, which kind of dealt with this here, y equals kx, and other things along those lines as far as changing the power of the x. So now we're going to be talking about the graph of this specifically, which hopefully you've seen before. What does the graph of y equals kx look like for different values of k? So we're using this basic equation, changing the values of k. And we'll also be finding the k values here. So rate of change, maybe you've heard this before. Rate of change. This works perfectly for y equals kx. So it's just another word for slope. It measures the change in the y variable divided by the change in the x variable, where you probably heard it called rise over run. Slope is rise over run. Change in y or the change in x. They all mean the same thing. Just a rate of change. So rate of change, slope, kind of the same thing. And so we're actually going to go through the definition of slope. The slope of a line through 2 points, they label that x1, y1, and x2, y2. You've probably seen this before. If you have 2 points, you can find the slope between the 2 points by just subtracting the y's because the y variables are on top. So we do y2 minus y1 all over x2 minus x1. So why do we use subscripts in this formula? And what does it tell us? The reason why we have the 2 and the 1 and the 2 and the 1, it's there for a reason. So there's two different x and y values, x1, x2, y2, and y1. So they tell us which one to use in a specific order. So when we do this, we have to do y2 first, then y1, and then x2, and x1. It has to be in a very specific order. If you mix one of these up, the answer will be wrong. So what are some examples of slope in real life? So can you think of anything that has like a rate of change? One very common one would be, how about this one? A lot of times when you see the word per, it's a rate of change or slope. Miles per hour. Maybe you can think of some other ones that have that kind of wordage in it. How about dollars per hour? If you're going to go work a job somewhere, you get paid per hour. So it's usually dollars per hour. If you go to like work at McDonald's, it might be $7 and some cents per hour or $8 per hour. What else? You could also have, let's see. Maybe you could say dollars per year. Whenever you go to the gas station, you would check out. They charge you per gallon, so I mean how much money you pay per gallon. So a lot of these things, when you have the word per, that usually means it's a rate. It's one thing over the other. Example 1. Determine the slope of the line with the equation d equals 1/5 t, where t is the independent variable in time, in seconds, and d is the dependent variable distance in miles. And then we'll graph it without table. So what's the slope? If we have 1/5 t, well, hopefully you've seen this before, where you have the number that's in front of your x variable, or in this case, it's the independent variable, is your slope. So it's your rise over your run. So 1/5 rise over run. So we're going to start at the center point, 0, 0. Oh, man. There's 0. And we're going to go up 1 and then run 5. 1, 2, 3, 4, 5. Up 1. 1, 2, 3, 4, 5. Then we can go the opposite direction. Down 1 over 5. Like this. Down 1 over 5. And then connect them as best we can. So now we can graph it just based on the slope. So let's talk about how we find the slope. Let's go back to this thing here. As long as we have 2 points, we can find the slope between two. Find the slope of the line as long as we have 2 points. So let's try example. What is the slope of the line through 936 and 25, 100? What I would do is label these as x1, y1, x2, y2, and then we're just going to do our subtraction. Slope is y2, which is 100, minus y1, 36, all over x2, 25, minus x1 is 9. We do our subtraction, and then we divide. So we get 64 over 16, and you actually can divide them. Sometimes they'll become decimal, sometimes they won't. So do 64 divided by 16. That is 4. Say it's 4 over 1 or just 4. If I was putting it on a graph, I'd probably keep it 4 over 1. I hope you've done this before. And that actually finding slope is not new, hopefully. So we're going to do a couple more. We'll just slope a line through 4, 5, and 1, 3. Again, label it so you know which ones you're talking about. First point and second point. So the slope is y2, 3 minus y1, 5, over x2, which is 1, minus x1 is 4. So it'd be negative 2 over negative 3. If you have two negatives being divided by each other, it would become positive. This would also be a decimal, so you can either keep it as a fraction or this would be 0.6 repeating. Either one's fine though. Okay, we have 2 more examples. What is the slope of the line through negative 1, 2, 0, 3? Label it again, x1, y1, x2, y2. So y2 is first, and then minus y1, 3 minus 2, and then 0 minus a negative 1. If you're going to mess up at all, it's probably going to be with the negatives. You have 0 minus a negative 1. Notice that there's 2 negatives here, so that'll actually turn to a positive. So let's do the top first. 3 minus 2 is 1. The bottom is 0 minus negative 1, or 0 plus 1, which is 1. So the answer is 1. 1 divided by 1 is 1. All right, last portion. Slope of y equals kx theorem. The graph of the direct variation function with equation y equals kx. So what we say with this slope here is that it's a constant slope of k. That means the slope never changes no matter what point you pick. Every single time if you pick 2 points, you'll get the same exact slope by what we were doing back here, finding slope. So there is a website we're going to use to answer these questions. It's kind of neat. You can actually see the graph of these y equals kx change. So we're going to go to the website and I'll show you what it looks like. How does the graph change as the slope changes? So we're just going to look at these lines here and fill in the blanks for the options we have, A, B, C, and D. And we'll put them over here for A, B, C, D. So we go back here. The website I'll put on Teams. I think it's this one here. It's called mathopenref.com/linearexplorer.html. You can see that up there. So when you go here, I had originally hit, if you look at this one here, I had hit 0 here, and that just makes this second part 0, this plus B part. All we need is the A part where it says AX. That's essentially our K value. And then our A here, this is the slider. This is changing the A value as you slide this thing up and down. So right now you can even see the equation. It's Y equals 1X plus 0. We're not going to change that. We're just going to change the number that's in front of X. That's the K value by using the slider. So watch what happens. This is at 1. If I slide this up to 2, just look what happens. There's 2. And you keep going. 3, 4. See what happens? It keeps getting steeper and steeper and steeper. And then what if we go the opposite direction? Going down, down, down. And then if we go back to 1, what if we get smaller? 0.9, 0.7, 0.6. As we get closer and closer to 0, it flattens out. As soon as you get to 0, it is flat. And then we're going to go in the negative direction, negative 0.2, 3, 4. So you can actually play with this if you go to the website and see how, as we increase the negative sign, negative 2 up to negative 3, it gets steeper this way, but now it's going down rather than going up. Then you can play with it by going up and down with it. So we're just trying to match them to the options here, A, B, C, D. So what does negative 2 look like? Let's see. Negative 2 is right here. And if you have trouble getting it exactly on negative 2, so it's like hard for me to get it there, you can click on this options here and click snap to integers. And then whenever you change it, it will just go to the integers. They wouldn't have to worry about the decimal portion. So here's negative 2. Looks like that. So which one would that be over here? We'll just label it. Looks like it's going to be maybe this red one here. This is A. Because it's not super steep. What about this one here? What about 2x? Let's change it to 2x. So here's negative 2. And here's 2. So it looks almost exactly the same. It's just going the opposite direction. Now it's going up. So that would probably be the other red one, which would be here, B. Oh wait, we should probably compare them to the 3/4 on to see which one's steeper. If we go to 3/4, which is 0.75, 3/4 is 0.75x, then I have to not use the integers. So let's compare 2 to 0.75 and see which one's steeper. Here's 0.7 and 0.6. So it looks like when we go up to 2, it's actually the one that's really steep. So maybe we should switch them around. This one's a really steep one. So if you compare, 2 to 0.75, 2 is going to be a little steeper. So that means the steep one here should actually be B. And the same thing should happen when we go to the negative side. So the really steep one should probably be A here. Guess you should see how steep you're going with this one. This is not as steep. And then D is the same thing. It's just negative, so it's negative 0.75x. So these should be the red ones that just aren't as steep. So let me go to the negative portion of it. So there's 2. So here's negative 2. And then as we go down to negative 0.75, see how less steep it becomes. There's 0.7. So it's not as steep. So that should be the red ones. So the negative one is D going down. The one going up should be C. So B, C, D, A. So depending on how steep it looks, will correspond to the numbers that you're looking at here. I think that is everything for this lesson. So you should be able to maybe identify these graphs, especially like in the team huddle, You can identify maybe each one now that you've seen it by how steep it looks and compare them. If not, you can also go to the website that I just used. So it shouldn't be too bad after that. And again, the website here is mathopenref.com/linearexplorer.html. If you can see that, hopefully. All right. That should be everything. And now you should be able to do the rest of the Huddle Mastery and the homework.